In this video we're on to the Sharp microwave. I'm just going to do a quick power test on this because I'm pretty sure it's down. When you work on enough of these you know roughly how warm some water should get. And this is out of some sort of Sharp technical manual. We've got a 700 watt oven, so we need to do 60 seconds plus 3 seconds to let the magnetron warm up, so 63 seconds. And we've got a little formula to work out, which is basically related to this multiplication. Why they don't just say 4,187 instead of putting the 2 bits? I guess the 1,000s for the litre, so you can change the, or milliliter I should say, 1 litre of water. Then you got your temperature 2 minus your temperature 1, so just the temperature difference divided by the time. And they do recommend the water is at some amount of degrees, around 10 to 12 I think, when you start. You know, approximately 10 to 12 degrees Celsius. I can only find a old Fahrenheit thermometer. I don't know what happened to my mercury thermometer that's in Celsius, but what we can do is just play around with this and convert the degrees. Now the water here is going to be freezing, I'm guessing, because it's the middle of winter and it's been very frosty lately. Though at least this has been out of the tap for a little while. Yeah, I think it's actually colder than it used to be. Now it's around 32.4 degrees Fahrenheit, which I already looked at before, so same as it was before. It's 1.1 degrees Celsius. So we need to warm this up a bit, quite a bit in fact, about 10 degrees, which may take a little while. I'll give it a minute. There's the clear button. There. We can at least see how much it goes up in that time. Give it a quick leakage check, I guess. I doubt there's anything there. Normally isn't. Nah, I haven't even zeroed that. It's a little bit low, but it's not moving at all. Given this one's pretty weak, I think it's certainly less likely to leak as well. Obviously stir your thermometer around a bit, they take a little while to change. It's gone up above 40 by the look of it. In Fahrenheit we've got 42 I think. Which I think is still only about 7 degrees or something. It's finally warming up a little bit. About fucking time. So it's sitting around 62 degrees there. Depending where you sit the thermometer, 60 to 62. So put it in for another minute. Yeah, 62 up to about 76. So we went from about 16.6 to 24.4, so say 8 degrees in Celsius terms. So we're just go, in this case, 4,187 times 8, 4187 times 8, 33,496 divided by 60 seconds, which gives us 558 watts. So it's about 550 watts instead of 700. So definitely down. It definitely seems slow. Obviously this is an older oven. so they always were slower, but definitely down in power. Now maybe it could be a capacitor or something, unlikely though. Most likely it's just a faulty magnetron. Now most of these early Sharps, you need to buy a special screwdriver for them because they're Torx screws. I should have one somewhere. Is that the one? That's the smaller one, I think. Oh no, that's the, oh, it's close enough anyway. I think it was a T25 they used to have. This doesn't say much on it. Oh, here it is. T20 it should be. This is a T15 that you needed for Philips stereos. But Sharp microwaves often had two screws that were Torx. They're not security Torx, but that was standard there for a while for Sharps to use that. Not sure what age this one is. Around probably 1990 or something. This is a R4A30 or R-4A30. The original model numbers were R- and then a number like 4, 5, 6, 7. I think was the standard depending on the size of the oven. And then another 3 digits. Then they went to these ones with like 4R30, 4A30, not sure what all that meant, but they did start adding letters in there. Maybe they just ran out of model numbers or something. And this one's got screws on the end as well. Most modern ovens only have them on the back, but it certainly could stop them rattling and stuff when they put them on the sides. You just flick them up and then slide them back because they've got a sort of lip along there that holds on. So we've got one thermal there, another thermal there, Magnetron's upright going through the waveguide in the top there. Is that our fan guide? Looks like, yeah, that's letting, looks like this one sucks air in through here, probably into the cavity and then blows it back out. We've got oh yeah, cobwebs. Looks like the capacitor is from 1988. Let's take the tray out. So that's inside the end of it. Fan is flat in this one. It's a bit of a different design. So the air goes in through that top plastic bit we saw, comes back through. The fins of the magnetron are lined with the cavity, so this is why some of them have the fins lined up the other way around basically. The air then comes back through this side. Got a bit of a deflector there. Obviously there's a cover normally over here which seals this up fairly well, and there's your fan which actually sucks it. Which way? How does the air work here? We've got vents underneath as well. So maybe the fan actually blows it out through the bottom. There is a vent hole here, so it's a bit of a strange air path on this one. But it's basically designed to, yeah, suck through. Some blow the air sideways, usually an upright fan, sideways through the magnetron, and then like a cover into the cavity. In this one here, the vent in the oven comes straight through the vents of that, while the waveguide goes up over the top here instead of the magnetron poking into the waveguide. So it shows they did a few different things, but they're all pretty similar besides that. Not sure if there's any real advantage of doing it that way. It's a bit of a smaller magnetron, this one, not one of the bigger older ones. This has just got 4 screws through the top. So you've got 2 screws here, 2 through the waveguide there. So even those big holes, obviously, don't let the microwaves out, because we can actually see into the waveguide here. What have we got there? Is that something? I'm not sure why they got a screw there, but we've just got the waveguide cover. So pretty standard stuff. We could check the capacitor, I guess. See if that's got any issues. Let's far as value goes, again, we're going to have to short it out, but this one you really got to either remove the fan or drop the thing down, and it should still be earthed through the transformer, but don't take that for granted. So if we pull this out a bit, of course being careful not to touch anything, we'll just short the two sides to ground. And then short the two sides to each other, just to make sure. This has got the older square type diode and short protector, both in one assembly. They share a common terminal, they're crimped together, so that technically you had to replace these as a pair. Sometimes you could undo the crimp connector and reuse it. Sometimes I had a spare terminal on the capacitor you could use and just snip out the faulty part. But in this case, yeah, you could also buy the full assembly. It was a bit more expensive, but again meant more parts you had to stock for occasional use, which often I just had the diode and the short protector in stock, I think with no leads, and you just worked out what you needed to do for each oven. We disconnect one side of this. The short protector could probably stay in the circuit. But let's do a capacitor test. It'll no doubt be good, but 1.17, and it is a 1.13. So if anything, it's better than rated. It's a Nichicon, no PCBs. Yeah, it should have a 10 mega ohm discharge resistor, but like I say, never trust the discharge resistor to work. Cut off voltage, cut off circuit, and check high voltage circuit after 1 minute or more. So they're saying it's taking a minute, should take around a minute for that thing to discharge it at 10 mega ohms. But yeah, it's shorted out anyway every time. Never touch the things until you've shorted any possible voltage out of it. And yeah, this oven, I think we'll just scrap the thing. I think I only paid $5 or something for this to do a video on it, and then tested it and thought it seems a bit slow, even though it was meant to be working. But yeah, that's why you don't buy an old microwave from the tip shop without actually doing a power test or something, because they generally don't do that sort of thing. They'll at least check it's safe. But if it's a later model, it may well be working fine, but these older ones have often done many years of work. Now obviously all these transformers have a primary side, these two terminals here, away from the high voltage, even though this has got a high voltage filament probably going up to the magnetron there on the same side. You've usually got this lower winding, doesn't have any connections obviously to the high voltage section, and of course if the oven's going to run you need the controller, whether it's mechanical or electronic control panel on it to set the time and stuff. That has to put 240 volts into these things, so if the high voltage doesn't fire at all, check you've got 240 volts there. Here's another thing you should really check, so that can be a fault with maybe door switches or the actual controller. One thing we'll just have a look at, some of these controllers actually have a MOV or something like a metal oxide resistor surge protection. This one feels like it does, so this might just be the perfect one to look at. And if you get a surge, it can actually, there's a circuit board track from the active where one of these big connectors comes into it, and it's thin, and it's designed to actually blow the circuit board track like a fuse if that MOV clamps too much surge. So occasionally you'll get an oven, and I think it's more that the controller goes dead. So there's our MOV, TNR something, VRS1 I think they're calling it. That'll be active to neutral basically. And yeah, you can get a problem with this relay, usually the bigger one. that switches the transformer and all the high voltage section. If the contacts go in that or something fails in the relay, you may get no switching of 240 volts into the transformer. So it did happen occasionally, pretty rare, normally just high voltage faults in these things. But yeah, if there's absolutely no sign, if the oven sounds like it's running, the fan's going and everything, but you do not get the high voltage, you can't hear the transformer hum or the magnetron kick in, then check your primary is actually getting 240 volts onto it, or I guess 110 volts if you're in that sort of part of the world. One more screws, always one more. I'll have a quick look at the circuit board on this. And yeah, keyboards are a thing that did fail in them. So we've got our relays, that's our main connector. Okay, so I was thinking that was a bit of screen printing there, but basically the active comes in, most likely the active on this line here goes to the contacts there of this relay, this box here. There's a link to this other smaller relay. And then they switch, that goes to one output, that goes to another output, so that switches probably fan and light or something, that switches the high voltage section to come on. We've got our little MOV metal oxide resistor there, so it's between active and this one's likely neutral. We've got our transformer also across, and a very thin track there. You can see two pins like it's meant to have a link or something in there, and same with those, but nothing soldered in, not sure why they put those there. Maybe so you can put a link in later, that's probably the idea, I guess. But you'd normally just solder something across any of these pins on the board. Technically it should blow as easy as the original, but you do have a main fuse in this thing if needed. But if that MOV conducts a lot of power, which it'll just go short circuit if there's a high voltage across it, it'll blow that little piece of track out, and that'll take out the power to the transformer, which means nothing will run, no clock on it, nothing like that. So if you get a no clock issue, it's either a main fuse blown, or rarely it can be that little link blown off the board. And I used to keep these controllers out of old ovens because you'd scrap plenty of them, and it was very rare you ever used one, ever needed one. They're generally very reliable, electronics in them super reliable. Occasionally, like I say, you get a dry joint on or issue with one of the relays, just the contacts died in it, maybe from an extra large amount of use or something, or lots of on-off short bits or something. And the transformers could go open circuit as well, but very rare. They may have a thermal fuse in those somewhere. Judging by the fact it's got 3 pins, suggests it may well have one. Whether you can repair it or not and put another one on it, who knows. But generally didn't have to touch these, very rare to get one out at all. Unless you're actually changing this membrane keyboard part, which basically just is stuck on the front here. You can get something underneath there usually and just peel the whole lot off, covers the display and everything. All depends. I think this one you probably got to unclip this plastic bit to get it off because it's actually under this outer piece. But they all just peel off basically, and yeah, once they've had water or something in them, generally got to replace them. They were quite expensive too, so not always a viable repair on an older oven. But that was about the only time you got the controllers out, and the only other time was if you salvaged one because you were chucking the oven out because they didn't want to spend the money on the Magnetron or whatever. And I had a great big box of these things, and I don't think I ever really used any. I thought they might be useful as timers or something in something else, because of course you can put power into these, and you've got a timer you can run for set periods. You can punch in your time and set it to run. And I don't think I ever had a use for that either, so maybe we'll keep this one in case I ever want one now, but never did end up using one for anything, and they're quite large and 240 volts, so not the greatest thing on earth. You could disconnect those relays from the 240 side and use them to switch lower voltages. But that's about it. We've got some of these little square thermal fuses, not the round ones. That one is rated at 240 volts, I can read, or 250 I think it is. 145 degrees C, orient. Yeah, 250 volt, 15 amp, 145 degrees. And that's probably something similar. That one I can read it in situ. That's another 145 degree one. So they just slot out. I think occasionally these would fail as well. maybe not these square ones, but the old round ones, you'd just find one that was open circuit. And we've got the same setup here, a couple of screws, and the switch assembly comes out. Of course, sometimes these switch assemblies would warp and stuff and you'd have to adjust them a bit. I don't know if I ever had to replace one, but sometimes they would get out a bit, the plastic would bend and the latches wouldn't work properly or reliably or something, they'd catch. So I might have to tweak that as well. They normally just unclip again. These sharps have got this little tab here you press and then the switch should rotate, I think. You push it down and it doesn't want to do it. Oh, is that on a pin? I think you've got to rotate the other end then. So you rotate the top end. So press that tab, rotate it. It's got a pin on one end. I completely forgot about these sharp style ones. And here's another one, press the tab down. Really need 2 screwdrivers to do it. Or get your finger in there, press that down until you can rotate the switch. Come on, keep going. It doesn't want to go any further though, it's jamming in its actual little piece. Oh, it has the little pieces come up and gone into the hole in the switch, I think, so that's not a very good design. Yeah, that was it. Keep rotating it a bit further and we can lift that up, and they just unplug obviously with the spade terminals. Another one here. I do remember replacing a few of these. I guess we can have a look. That's just this little smaller switch here goes to a connector on the control panel, just to tell the control panel that the door's shut, because otherwise it'll block it from running. So that's another thing, if you try to use one of these control panels for a timer, you need to short a couple of pins out there to enable it. That switch normally never caused any issues, but these other ones would get bad contacts in them occasionally, or grease in them, which probably help with the contacts getting bad. And again, we can just prise the side off it and inspect it. That one is pretty much mint condition. Not a single bit of burn on that. A little bit of tarnishing, but that normally didn't matter. A lot of them did get pretty tarnished. But underneath where these spade connectors fitted, they were fine. And internally. But if you've got an intermittent blown fuse issue or something, it might be worth replacing them anyway, because they would cause some silly issues like that. Yes, that's quite tarnished, but the bit where the actual connection is fine. That's it, go to those little slots that usually help. That's it. Oh, that I can see burn mark already on there. Yeah, that one's pretty blackened. The main bit's not too bad, but you can see it's been arcing around there. You can take this other piece out as well. Can be cleaned up, but usually better if they've been causing trouble to replace them, but always worth an inspection. So that switch probably isn't much good use as a project switch or something, just as a spare part best thrown away, but I guess we could probably do something with it. Here's another one, again extra corroded on that one, it's even got grease on it I think. And yeah, dust and dirt, so that can cause this little actuator to stick, or just to, they'll go slow sort of thing. Anything like that can cause them to blow a fuse if one of these switches doesn't operate with the others. And that one's again pretty good condition I think. Yeah. So that one's quite usable. That's a bit dirty. And just the last one, we won't even look inside that one. But I may have a project for a few of these switches, so I think I'll hang on to those, even the slightly burnt one. What do we got? These are all the same type. So this oven's actually got all the same type in them. Oh no, one of them's different. So ones are normally closed. Yeah, it's an NC, so normally closed, the rest are normally open. Usually there's at least 2 types in them. No high voltage fuse in this one. Also has a large resistor in it, which I can't remember on the circuit what that actually did. What's it in series with? Oh, that's across the transformer to one of the switches. It's a 0.8 ohm. Was that meant to short it out if there was a fault or something? If the switches didn't operate, possibly something like that. Looks like 20 watt at 0.8 ohm. Most ovens don't have one of those in them. Salvage a couple of thermal switches. But not really worth a bother. Normally you'd have some new ones of those in stock in case they died, but of course different temperatures made it difficult to keep all the right stuff in stock, and they were only rarely used, so I think I normally just ordered them in if I need them. Most people wanted their ovens repaired quickly usually, but you could get them overnight or whatever if needed. They might just have to pay extra postage. And we can take, what do we got here? These usually have screws. I think there's that screw there to get the fan assembly out. If you've got to get the Magnetron out, you've got to get the fan assembly out. And the rest of it just clips mostly, I think. So anything else, it's got a couple of clips in the back panel. Everything holds it in. Maybe you've got to get the Magnetron out to get it out. I think in this one you may do. You've got a cover on the back if you want to get the light bulb out. And what holds it in? One screw to get the socket out. There's our lamp, which was still running. Besides being a bit of a handy test load for switch mode power supplies and television, not much use. Though they do use some of those small lamps and other things these days. Disconnect the fan, disconnect the transformer. This has got the fuse holder on the base here, which is a bit different. Nice chassis mount fuse holder if you need one for anything. But most people use panel mounts so you can access them from the outside. So nice chassis mount one with spade terminals, quality part. That fuse doesn't say on the outside what it is. It's probably 8 to 10 amp normally. Power cord, then as always, remove your wiring harness from the turntable motor that's underneath. Magnetron, we just take the 4 screws out. I'm not sure if these ones are easy to get apart. I don't think this type, oh, it does have the same sort of design, so this is different to what I was expecting. It doesn't have the tabs on it. Tabs make it easier to knock the top off them if you want the magnets. Usually best to put your hand under the Magnetron to stop it dropping. In this case the fan stuff's going to hold it. There it is. A couple of terminals off that and we've got that one. So this is a tabless one, and like I say, the air vent on the same side as the terminals. Sharp A079 WREO, so that's the Sharp RVMZ of 2M237. That was the sort of numbers most Magnetrons had, 2M something. That also helped find which one was the correct replacement. Made in Japan. Danger, high voltage, etc. Magnet. Keep the Magnetron away from the magnetic materials. Yeah, definitely don't put it near your CRT or your video cassettes or something, because that's quite a strong magnetic field. And now the fan just pulls right out. Once we get the wiring detached, another fan the same. Again, should be able to just pull the force the blades off it. This one's got the glue stuff on it, the lacquer, the dreaded green lacquer that they put on everything. It's starting to come. And that's that off. And then here I think we actually got bolts with nuts. You can salvage that if you want to. Looks like we've got another sharp part number on the side there, made in Japan. Those bolts with nuts are actually quite handy for things. I think those nuts should just poke out afterwards, although these have got lacquer on them as well, so this is some of the latest stuff they lacquered up, which is a bit of a pain. And this one's been a pain. Something I used to do for scrap metal purposes is just snip these things like so. Then it was acceptable to the scrapyard, probably not so much if you got tons of plastic with it. And actually I didn't need to cut all of it because we only got one piece holding it there anyway, so that can go in the scrap. And we've still got a capacitor joined to the transformer here. Get rid of that. I usually toss that metal bracket away because it has no use other than for this model. Stuck on a bit more than usual, and if we take that off, get rid of that plastic. And yeah, good spare capacitor, good spare diode, and short protector assembly, rather tarnished, but doesn't matter. And we'll take the transformer out. This one looks like it comes from above, 2 screws and slots out. Another sharp number, RTRN. And 88 might be the year, but looking at this one, and the good thing about Sharp is in their service manuals they gave you a code. You could look up the part number and they'd have a code next to it, and that would tell you the parts price. You just have to talk to whatever Sharp agent you're dealing with for the parts, and they could say it's an AZ or something code, and they'd just look that up and tell you what it cost. So no need to fax people and whatever to chase prices. If you could get access to the service agents manuals, you just look it up yourself and get them to find out. Saving a lot of hassle. And we'll take the power cord off. Oh, 2 screws actually on this one to get the motor out. So it's got a big long cover. Quite an open bottom on this one too. So I guess they thought they could save a bit of money on the bottom cover, which would normally cover all this. So they've just removed that bit and just put the cover on there instead. And there's our motor. I've already cut those wires, so they'll come through. And there it is, we can remove the wiring. Not sure that's a Sharp. Oh yeah, there it is, Mote DA091, so that was always handy having that as well. It's a Sankyo Seiki Manufacturing Co. They made a lot of cassette player motors and stuff, so I guess why not make turntable motors. Probably made turntable motors of the record playing side as well, and the microwave side. And we had a washer on there, and you can just put your hand in there now and pull with a bit of fiddling around, this coupling comes out. It's got a little bit of an eccentric thing that stops it coming straight out of the hole. You've got to sort of slide it across and lift And like I say, they would occasionally fail for either that someone overheated something, or sometimes they cooked in some of these models on their own. But not much use these days. And we've got the old waveguide cover in there. Quite a dirty one. So just get a little plastic clip out of that. Can push it from above at the moment too, helps. I think I need to get a pair of either needle nose or side cutters under them. Yeah, side cutters are probably better, and just carefully prise that out. Some just have a screw or whatever. And I do remember cutting many of this shape of waveguide cover out. These used to cook up quite regularly, and that's part of the reason, because those greasy patches and splatter marks will start cooking if it gets bad enough. This one's actually pretty clean, even though it doesn't look the best. Often it'd have a whole layer, you can see a little bit under there, but it'd be greasy to the touch. It'd be all greasy on there, so it'd be greasy there. Possibly because it's been sitting around so long, maybe it's dried out or something. And there's just a little metal pin up in the waveguide cover where there was a screw from the top there, so it comes along here and then it hits a pin to scatter it a bit. Plus the tray to scatter the thing. I won't bother pulling this door apart because we've already done one. So that's ready for the scrap steel pile. So we'll have a look at dismantling the transformer and the magnetron. Yeah, normally they have a couple of tabs sticking up, but it's the same sort of process. They've put the top cover on, bend a couple of tabs underneath. So all you got to really do, sit that down. A bit harder with these ones because you've got the pins on one side. But sit them on their side even and just whack that bit with your foot on there, and it'll just break that free. It'll bend those tabs, and then we can just pull everything out from the top, and that'll get rid of that. This one's actually got a bit of that aluminium there, has lifted on the copper by the look of it. Ugh, let me point at it without stealing my screwdriver with your magnets. But yeah, the fact that's up there, in this case it might be, or it looks a bit scratched. Sometimes that can be a sign that this has been overheated, but they're all actually in place by the look of it, so maybe that's nothing, maybe that's just where they put it on in the factory. But that's the kind of look you'll get. Sometimes these will actually be bent up and stuff, and that central bit will actually be sort of peeling back a bit. It's not a tight fit on there. But the magnets look fine. Yeah, I think that one is okay. So we'll have a look at dismantling the last bits and turning it into proper scrap metal. Okay, to get one of these magnetrons apart, got the bracket facing out the other way. Oh, maybe we'll do it on the side. I used to just put my foot on there. My nice dirty gardening boots here. And that's all you got to do. Pretty simple. This bit then comes off. Magnet. And, oh, geez, that's tighter than the usual. This is a bit newer than the ones I used to do, but should be able to just pull that piece out. There we go. That's catching on something. There we go. Pull out your couple of wires. Because that magnet's got stuck, that magnet just pulls off as well. And I used to just cut them there. You lose a couple of cents worth of stuff. Watch your fingers. Oh, they'll pinch you. So a bit of copper wire. That's a bit of aluminium on some copper and a bit of ceramic. And yeah, of course steel. And yeah, a couple of nice magnets. There's our little ferrites that the wire was wrapped around. Oh, one must be snapped in half maybe. Oh, we actually got 3 bits of ferrite. 2 little ones and 2 big ones. Maybe they do them different now. If you're really game, you can probably... I think these will peel off. They're only press fit, I think, from memory. But you may have to cut them to do it. Really not worth the time, I don't think. Because they got that little bit. And they're sharp and dangerous. If we can get down there and cut that bit. Maybe you could do it with a grinder or something, but again, for a little bit of aluminium, that weighs hardly anything. That is just nothing.
probably an aluminium can if you're lucky, and you can see the copper showing there, and you risk more scratching of this, but there shouldn't be anything toxic in that, because it's super expensive, that stuff anyway, and these are made to be cheap. And yeah, 2 nice magnets. I think they've got slightly smaller holes than a lot, but yeah, whatever you do, don't get your fingers over the edges. If you get your skin in there, it'll pinch you, and you'll likely get a nice big blood blister and quite a bit of pain. Let's have a look at this other one. This is a sharp one. Should be the same process. So this one's a bit harder. Probably have to put a foot, something like that, and not so easy. These are probably ones I wouldn't have bothered doing once. Yeah, much harder to get apart. You could probably prise them with something. This one's just starting to come. And we've chipped the magnet a little bit. Oh, we've got to get that metal bit out of the way. Just watch you don't cut yourself on that. Probably best to prise it with something. Some come straight off. Some are well pressed in. And that's another magnet. It's only a smallish one. And yeah, just takes a little bit of a knack to do that. Hold that. That actually broke off, so that's even better. And I should just pull out a bit of useless ferrite. And yeah, we did chip these ones a little bit. Not the end of the world for what they're going to, I don't think. Now, just being careful, grab it by the edge. Shouldn't really do that at all, probably. But they're great for going around and collecting up bits of screws and whatever. That bit's definitely magnetic, bits of ferrite. I actually had a metal plate about so long with however many it took to fit it, and just hung it on a couple of bits of wire and went around the backyard, and you could get any nails and stuff after doing renovating work and recycling used timber and stuff. Pulling nails, ones you always drop a few of them. But that's basically what you get out of a couple of old magnetrons. Yeah, we've got a couple of slightly different size. Magnets are not often all that consistent. Well, they're not even the same thickness, those ones. These are more like the earlier ones, all used to be very similar. Larger, same thickness, but as things get newer, like usual, they start changing everything. But that's how you get those apart easily. We might have a look at a transformer and do this on your old concrete, not your good concrete. Yeah, so I always assumed you'd have to cut the weld with something, but I guess we can try maybe with a hammer, and if not, let's not sit it on any soft wire. Oh yeah, look at that. Easy. That's a lot easier than it looks like it's going to be. So I just gave that a whack. I assume those welds went in nice and deep, but they're only surface deep basically, and we should be able to bang all this stuff out. Probably best to sit these coils on something, or the metal on something. Can we use that bit? The general idea is that we can use these old magnetrons, and we just need to use something like, use a bit of this other coil bit, lamination bit, and that's it. Usually once you get some of it out, not so hard. Coils digging into that. Yeah. Oh, we bent it. So something a bit more solid it might do. How long is this bit? This probably... Let's just knock some new stuff out of there. And it's all disintegrating, of course. We just made it. So the problem is you've now got a very dirty piece of copper. Oh, looks like it's got mica in there. I think the newer they get, the worse they get. So even to get number 2 copper, you've got to clean all this stuff up. You've really got to cut all this stuff off, get rid of that tape. So yeah, not overly worth it unless you're scrapping for a living or something. Sometimes you can tear that off with some cutters. Similar to recycling old yokes and stuff that used to have all this rubbish on them. And you'd have to try and remove the bulk of it. Cut those terminals off. And we got whatever this stuff is as well. I think that can probably be, that does tear. Probably be cut with a knife or something, or does it actually unwrap with, if you get it the right way. And there's more tape under it, of course. So there's probably a technique to this once you get the hang of it. That makes you a lot quicker. Could probably shove a screwdriver or something under these and start tearing. Here we go. But, yeah, a lot of rubbish and a lot of mess for, I wonder if that is that. It should be copper. It doesn't actually weigh much. I hope that's not aluminium. Must admit it feels like aluminium a bit. Oh man, I think I got aluminium. I got ripped off. Yeah. Your modern cheap ovens, so that's only aluminium anyway. Pretty sure that's all we got there. We got a heater coil. That might actually be real copper. So I forgot a lot of this stuff is now made out of aluminium, so it's really just irony. Aluminium is probably the right place to put it. This looks like it could be copper. It's very fine, but doesn't mean it is. And we've got to work out how to get this off. It's all got lacquer and stuff on it. It can probably at least go as PVC at the moment, which you've already lost a lot of your weight. And we're just going to keep ripping away to even get to this stuff. Maybe you can prise these whole pieces off it. They're surprisingly well stuck on. Yeah, it's going to tear, I think. I'll make a mess everywhere. Slowly coming. And you've still got plastic and every kind of rubbish under it. Gonna make a hell of a mess everywhere. So these modern ones, like most modern things, are much more work than probably the old ones. And barely worth the bother, I think. Right. Yeah, just a nightmare, really. But yeah, I've never bothered to take one apart. It's the first one I've ever took apart. And I must admit, I'm glad I never bothered. But copper is worth a lot more than it used to be. So maybe it's worth it, but like I say, you got to get all this tape off. And how you start it. Some of this stuff's just horrible. You almost have to burn it off, I think. That at least feels like it's copper, but whether it really is, where did that wire go is the next problem. Disappeared, I think. There's a bit the end of it. Man, that looks silver as well. Surely this is an all aluminium wire. Yeah, given how easy it breaks, and it does look silver. Yeah, it's silver. Rubbish. rubbish. And this is all like fiberglass coated stuff. That might actually be copper in there, who knows. No guarantee even with this. It's pretty solid whatever it is, it's silver coated. I'd say that's copper, or unless it's steel or something horrible, which is not impossible in the modern world. It's almost like it is. There's copper in there, I can just make out the copper colour. So at least that's worth something once you cut the ends off it. So I've got, a cent's worth of PVC. That, let's hope this is even copper, because these days who would know? Feels like it's something hard. Yeah, it looks like it. But it goes to show this colour on the outside means nothing as to what's inside it. Philips used to do something similar in their TVs for degaussing coils. They could be blue, yellow, red, all sorts of different colours, sometimes this sort of copper colour, but they were aluminium inside. So it's not that new, they were doing it in the 70s as well. But anyway, that great big destructive mess. That's what it all looks like. There remains the 2 magnetrons. We've got 4 magnets and not much else out of that lot. And 1 transformer that was complete rubbish in the end, should have gone in the iron alley. So it probably pays to file your windings first. And if they look like aluminium, just throw it in the iron alley complete. Not worth any time to pull it apart. Older ones should be copper. But that was a fairly new oven. If I pull the old sharp one apart, it should be copper, but I might even keep that as a spare in case I need it. But anyway, that concludes this video, I think, so thanks for watching.